This is Algebra 2 with trig, 3a.2b. What we're looking at today is y equals ax plus b over cx plus d. What this is two different linear equations, one for the numerator, one for the denominator. This is still considered a simple rational function to graph because there are only two branches. Now what we did yesterday we worked with an equation y equals 3x plus 1 minus 4. That may have been a possible graph that we did yesterday. And what we would have done yesterday is we would have made a table working with 3 over x. So we would have wanted to x's and y's. We would have picked values that worked well with 3. First we'd figure out our asymptote was 0. Then we work with numbers that worked well with 3. So -6, -3, and -1 work well with 3. And we could calculate what those would be. And then we could plot those out. And we'd be over here. And we would calculate values to the other side, and we would get values over here. Then we would translate 1 unit to the left, 1 unit, or 4 units down. We would have taken all of our points, and that would have brought you to the correct sides of your asymptotes based off of your dashed lines, doing the translation of 1 to the left and 4 down for every point that you did in your table. Today's a little bit different. Today we don't have that basic graph. So we're going to only make a single graph today. When the degrees of the numerator is less than the degree of the denominator. Well, that's what we had yesterday. Take a look. The degree of the numerator. What is the degree of the numerator? You look for the x value to determine that. This would be considered x to the 0 power. There is no x. So it's x to the 0 power. The degree is 0. The denominator, you look for the exponent on the x. So if there's nothing written on your x, that means it's the degree of 1. So the degree of the numerator is less than the degree of the denominator. That's why we had a asymptote at 0 originally. When the degree of the numerator is less than the degree of the denominator, then the asymptote is at y equals 0. You just got to watch if there's a k value that then moves it differently. This is what we're doing today. When the degree of the numerator is equal to the degree of the denominator, then the horizontal asymptote is the ratio, or the fraction, if you like that word better. It's the fraction between the leading coefficients. So what we're going to do when we look down here, here I have a degree of 1 and I have a degree of 1. They are the same. So I'm going to use my leading coefficients. So my horizontal asymptote is y equals 3 over 1, or 3, because that's my leading coefficients. And I look at my leading coefficients if the degrees are the same. That's because as x gets really, really, really big, When x is 1,000, 3 times 1,000, the minus 6 is pretty irrelevant. It doesn't really change much. It's 3,000 minus 6. And 1,000 plus 2, the 2 is pretty irrelevant. So it's really only using those x values. Also, what we did yesterday, we didn't talk about it so much yesterday, but x plus 1, we talked about how the asymptote was moved 1 to the left. We always just talked about it being the opposite of what's in here. But that's because you could set it equal to 0, do the math, and you see that it went 1 to the left. To find the vertical asymptote, you must set the denominator equal to 0 and solve. So we're going to come down here to find our vertical asymptote. We're going to take our denominator, and in your homework I would expect you to write these things out. It doesn't just magically appear. Subtract the 2 across and you get x equals negative 2. So we're going to have a vertical asymptote at negative 2. Don't forget to label the asymptote. And we have a vertical, or actually a horizontal asymptote at 3. So label the asymptote. So now we're going to focus on our table. I'm not a big fan of tables, but in this type of situation, it would be pretty much required because we don't have a parent function to follow. All right, to make our table, this is going to take some calculations. It's going to be a little intimidating. But this is 11th grade math. It's Algebra 2 with trig. You can do some basic calculations. First of all, what is your vertical asymptote? Negative 2 is the vertical asymptote. Nothing's going to happen at negative 2. You don't get a point at negative 2 because that's what makes the denominator 0. That's why there's an asymptote there. We need to pick numbers to the left of it and numbers to the right of it. Well, in yesterday's lesson, we talked about what numbers worked well with the value on top. What numbers worked well with 3? In this situation, it gets a little complicated with that 6 and 3x. And so we're not worried about trying to predict what numbers would work well. Let's just spread the numbers out a little bit. Don't cram them in real close, or else you only get a few dots that are real close to each other. So I would suggest going 2 values away, 2 values away, and 2 more values away. So that means going to the right, what numbers are we going to use? Yesterday, we would have copied those, but as positives. That's because the vertical asymptote was at 0. We did a distance of 2. So a distance of 2 would take us to 0. A distance of 4, so a distance of 4 would take us to 2. Right? So we're counting by 2's going to the right. So now we've determined our x's. And it really doesn't matter what x's you use. You can use any x's you want. There's no rule. I'm just trying to give you some pattern to use. Spread them out a little bit. That's good. So now we have to do our calculations. We only have to do 3 calculations. That's why this is somewhat reasonable. So we're going to do when x is negative 8, we're going to plug negative 8 into our equation. You can do this. 3 times negative 8 minus 6 over negative 8 plus 2. That's negative 24 minus 6 over negative 6. You cannot cross the 6's out. This is negative 30 over negative 6. That gives us the value of 5. So when we have negative 8, we're going to be at 5. Now we're going to work with negative 6. So it's 3 times negative 6 minus 6. Negative 6 plus 2. This first portion is negative 18 minus 6. And this bottom is negative 4. That's negative 24 over negative 4. That's a value of 6. If you get a fraction, you get a fraction. Not a big deal. We got nice whole numbers. X equals negative 4. So 3 times negative 4 minus 6. Negative 4 plus 2. That's negative 12 minus 6 over negative 2. That's negative 18 over negative 2. And how many times does that go in there? 9. So we have 9. You could continue that same process off to the right. But like I mentioned before, tables aren't my favorite thing. So I would rather you use as much 11th grade math as we can. So let's use symmetry to do that. Unfortunately, it's not going to be 9, 6, and 5. That is not right because our vertical asymptote is not at 0. It doesn't work the same way as yesterday. But because this is in our table, these are real coordinates, so we're going to use our origin. We're going to go 8 to the left. And we're going to go up 5. Then we're going to go 6 to the left and up 6. Then we're going to go 4 to the left and up 9. So 4 to the left and up 9. So we plotted our points. And you see how they're somewhat spread out. Now we have to figure out where they go over here. Where a hyperbola is very symmetrical. That's the neat part, using our 11th grade math knowledge. So considering our asymptotes, making a new origin right here. Notice what we have to do to get to this point. We have to go 1, 2, 3, 4, 5, 6, and up 2. So from that same imaginary origin, we're going to go 1, 2, 3, 4, 5, 6, and down 2. Where am I at? I'm at 4, 1. I can fill that in on my table. And I didn't have to do all the math to figure that out. My second point from my imaginary origin. 1, 2, 3, 4. Up 1, 2, 3. So we're going to go 4 to the right. Sorry, lost. Oh, and down 2. Down 3. Sorry. From here we're at 1, 2, 3, 4. Up 1, 2, 3. You got to count. You got to know your numbers. So to the right 4 and down 3. So that puts me at 0. Now from our imaginary origin, we go 2 to the left and up 1, 2, 3, 4, 5, 6. So from our imaginary origin, we're going to go 2 to the right and down 1, 2, 3, 4, 5, 6. That puts me at negative 3. And there's our graph. We put in dots to represent our exact locations. We put in our asymptotes, and we label our asymptotes. So we know our vertical asymptote, the one that goes up and down, was x equals negative 2. The horizontal asymptote, the one that goes right to left, is y equals 3. What's our domain? In other words, what x values does this graph go through? Or what x values are appropriate to plug in to our table? All real numbers, except where we have that asymptote, that x equals negative 2. We can't plug in negative 2 because that makes the denominator 0. Otherwise, you can plug in any number you want. You'll get an answer. What's your range? What answers are you going to get? All real numbers except y equals 3. You can get any y value, but you can't get the asymptote number. Okay, here's a story problem. Hooray. Your long distance calling plan. Now you don't really even know what that means. There were actually long distance calling plans where if you were going to call outside of your city, it cost you different than if you were to call right down the street. This calling plan, you had to pay $4.95 every month. And you also had to pay 5 cents for every minute that you used it. So we're going to make a graph. We're going to write an equation that gives your average cost C per minute during the given month. What is the average cost per minute? Well, C, so what's our cost? Our cost is 5 cents, so we need to have it be the same units. So we have to use 0.05. We don't use 5 because that's going to look like dollars. So 0.05 for every minute, so 0.05 M. But there's also an upfront fee of $4.95. Now that would be your total cost. How are we going to turn this into an average of per minute? So if this is your total cost, when you put in a 10 here, then you can figure out how much you totally paid. Or if we want to figure out per minute, we're going to divide this by the number of minutes. So now it looks a lot like the math problems we've been graphing. We have a variable on top and we have the same variable on bottom. We've just made this equation from a story problem. So this is the cost that it is for the month, and this is dividing it by the number of minutes to figure out what did each minute individually cost me. So we're going to make a table. we have minutes, like for the X's, and we have our total cost for our C's, for our Y values. They're suggesting that we look for values of 20 minutes, 40 minutes, 60 minutes, and 80 minutes. So, like many word problems, we're going to use a calculator in this case. We won't force you to do this portion by hand. What we're doing, we're going to talk for 20 minutes. So that is 5 cents for 20 minutes. That's a certain amount. It's like $1. Plus the $4.95. So that's our numerator. That's going to give us $5.95. That was the cost to talk for 20 minutes. But if we divide that by the 20, now we know how much each minute cost us. Each minute costs us 29 or 0.297. So in terms of my graph, that is just a smidget underneath 0.3. If we're going to do 40.05 times 40 plus our $4.95, that's a $6.95 fee. We're going to divide that by 40 to see what each minute individually cost us. And that's 17 cents per minute. So at 40, we're at 17 cents. So that's a little bit below 0.2 for 20 cents. 0.05 times 60 minutes plus our $4.95. That's a $7.95 fee. But if we wanted to know how much did it cost us per minute to talk, it cost us 13 cents per minute. So that's a bit above 0.1. And then the final one that we're looking for is 0.05 times 80 plus the $4.95. If you talked for an hour and 20 minutes, which is 80 minutes, it would cost you $8.95. Each minute individually, if you divide that by your minutes, it's going to cost you 11 cents. So using knowledge of what we've talked about before, what is this graph approaching? If I go out far enough, like if I say 5 cents for 1,000 minutes plus the $4.95, it's going to cost me a lot of money divided by my 1,000. What is this going to approximately be? Is it going to approach zero? Is it going to eventually get down that if I do enough minutes, it's going to be like almost free? You can't be any cheaper than what it costs you per minute. Right? So what was our rule about if the degrees were the same? Then you use the leading coefficient. You use the 0.05. So the 0.05, which would be right here, would be the asymptote. That's what it's going to approach. It's going to approach 5 cents. You're never going to get lower than 5 cents per minute. So what happens to the average cost per minute as the number of minutes increases? the average cost approaches, it'll never reach it, approaches 5 cents. And then in summary, the graph of the function y equals 1 over x is a hyperbola. The graph of the function y equals a over x minus h plus k has asymptotes at x equals h and y equals k. Those are some notes that we learned about yesterday. The graph of these simple rational functions are called hyperbola, which is made up of a curve with 2 branches. We're going to do 3 branches in the future. These graphs have one vertical asymptote and one horizontal asymptote. We're going to have 2 vertical asymptotes in the future.